Lenses and eyesight. Looking at some convex lenses are thick in the middle and thin at the edge. And they are converging lenses, and that means parallel light rays are going to focus or converge into the focus point. You can see the fatter the lens, the shorter the focal point, and the thinner the lens, the longer the focal point. Now this should make sense because if your lens is so thin that it's actually flat, then that focus point becomes infinite and these light rays just stay parallel, they don't bend. Looking at the magnification, the thickest lens magnifies the most, going down to the thinnest lens magnifies the least. This should also make sense because if the lens was so thin that it was flat, then it wouldn't magnify at all. In your eyeball we have a convex lens. And it has to be a convex lens because that's the lens that can create the real image. So we have our distant object here. These light rays come in parallel. They focus to the focal point, which is right on the back of your eye, which is called the retina. Remember, the real image is going to be inverted on your retina there. Somebody who's nearsighted suffers from the condition called myopia. And if I go between these two pictures, you can see that the nearsighted person's lens is a little bit thicker than it should be. The thicker lens has a shorter focal length, so it's focusing before the retina. We say that the image forms too near the lens, and that's where the word near comes for the word nearsighted. So to correct this, there's two different ways. In the last 10 years or so, they've been doing eye surgery where they take the lens out of your eye and they shave it down thinner and then put it back in your eye. And that way we can focus the light where it's supposed to. I have a story to tell about this. If we have some time one of these days, you can ask me. The other way, the normal way we solve for myopia is eyeglasses. And the question that I get asked is, are my eyeglasses convex or concave? Looking at the light rays here, we need to spread these two light rays farther apart from each other so that focus point moves down onto the retina here. So the lens that spreads light apart is the concave lens. This is a diverging lens. The way it works, the diverging happens between the lens and your eye, so these light rays get diverged, and then when they go through the lens or the plane of the lens, they will focus onto the retina. The opposite of nearsighted is farsighted. This is called hyperopia. For hyperopia, these light rays focus too far from the lens, so it's beyond the retina here. To solve for this one, we're going to need the other lens, a converging lens, because we need to converge these two light rays closer together to move that focus point up. Going back to the normal eye, if we have a distant object, the distant object is supposed to focus right onto your retina. If we move the object up closer, then the DI moves away from the focus point. When you're looking at something that's up close, you have to focus on it. And what's happening, your lens is made of like a squishy material, and you have muscles around your eye, inside of your eye, that squeeze the lens to make it fatter. And the fatter lens is going to shorten this focal length, and it moves the whole picture forward, so that image that does have a DI now is actually landing on your retina. As you get older, what happens is your muscles in your eye get weak and they can't focus anymore. They can't squeeze the lens anymore. And so this image is too far away from the retina. So the person has to get reading glasses, and the reading glasses are also converging because we want to bring these two light rays closer together to shorten that focal length so we can get that image back onto the retina. For the nearsighted person, normally if the object's far away, the image is going to be blurry because it's not on the retina. If we move the image up closer, then the DI moves away from the F and we can get the image onto the retina, and it will be in focus without having to adjust our lens, without having to focus on it. So a nearsighted person does see things that are near to them in focus, and that's because this focus point is in front of the retina, but the short distance makes a longer DI. The advantage of being nearsighted is when you get old and can't focus anymore, you don't need the reading glasses because your eye is already focusing a close object onto your retina. End of notes.